Okay, so we have a couple of additional identities that we need to make sure that we understand, and we have even and odd identities. And an even function, so if I ask you if a function is even or odd, what that means is your original function f of x is equal to f of negative x. All right, so what this tells us is that we have symmetry with respect to the y-axis. And WRT means with respect to the y-axis. And the most common function that we know that has symmetry with respect to the y-axis, our example would be a parabola, meaning the graph is symmetric on both sides. You could literally fold your paper and you would get the same thing. So here you could paste these on either side of the points. Okay? So a parabola is a good example. And an even function, how this works is if we have the cosine of theta, that would be equal to the cosine of negative theta. Okay, so the secant of theta is going to be equal to the secant of the opposite of theta. So let me show you how that works. Here, if we're saying we have the cosine of 30 degrees, this will be equal to the same thing as the cosine of negative 30 degrees. And what I want to show you is, if we're on the unit circle, the cosine of 30 degrees is located here. And the cosine is positive here, whatever that value is. In this case, this would be positive square root of 3 over 2. Okay, now the cosine of negative 30 is located here. Negative 30 degrees is in the fourth quadrant, but cosine is also positive here. So this is also the square root of 3 over 2. That's why this works. That's how an even function will work. Now, an odd function is the opposite of f of x is equal to f of negative x. Okay? And what this means is we have symmetry with respect to the origin. And the most common function that we know that is like that is our cubic function, meaning I have 0, 0, so I have the point 1, 1. And the way I think about this is an odd function is exact opposites, meaning if this point is 1, 1, you're going to have a point negative 1, negative 1, which is actually down here. So this is negative 1, negative 1. And it would be the same for this. Another way you can think about this is you would have a 180 degree counterclockwise rotation. And you're going to get the same thing. Meaning, if this here is your original, if I rotate this 180 degrees, it's just 180, the graph looks exactly the same upside down. Okay? Alright, so odd functions are the opposite of the sine of theta is equal to the sine of negative theta. Same thing for the reciprocal function, which would be the opposite of the cosecant is equal to the cosecant of the opposite. Okay? And then the same tangent is also an odd function. And so is cotangent. Okay, so what we have here are these. And I'm going to give you an example of that one also. So if I said to you, find the opposite of the tangent of pi over 4, what you need to remember is that pi over 4, remember this is my favorite one. Okay, pi over 4 is in the first quadrant. This answer is 1, so that means this answer is negative 1. What we're saying is this will also be equal to the same thing as the tangent of negative pi over 4. Okay, negative pi over 4 is located in the fourth quadrant. Okay, and this angle right here is equivalent to the tangent of 7 pi over 4. And I'm going to show you on the unit circle. So negative, if this is 0, negative pi over 4 would be located here. Okay, it's the same location as 7 pi over 4. Remember, it's a coterminal angle. Okay, and that means the tangent value is exactly the same. Okay, -1. So that's how odd functions work. Okay, all right, so I'm going to do 2 examples, and I will take you through this. All right, so here it says find the exact value of each expression using Pythagorean or even odd properties, and we can't use a calculator. So we have the tangent of -5 pi over 6 minus the cotangent of 7 pi over 2. So first of all, this negative's on the inside, so because tangent is an odd function, that means if I can take the opposite of the value of the tangent of 5 pi over 6, and I will subtract the cotangent of 7 pi over 2, but I need to figure this out because this is greater than 2 pi, which would be 4 pi over 2. So if I take 7 pi over 2 and I subtract 4 pi over 2, this is 3. Oh, periodic. I did this wrong. So this should be 2 pi over 2 because remember, tangent and cotangent are periodic with respect to pi, not 2 pi. So that means this is 5 pi over 2, which is still too big. So I need to subtract another half a revolution, which would be pi, so this is 2 pi over 2. So then I have 3 pi over 2, which again, minus 2 pi over 2 is pi over 2. Oh boy, struggling. Okay, so what this means is the cotangent of 7 pi over 2 is the same value as pi over 2, which we know is 90 degrees. So we want to know what is the cotangent of pi over 2. Okay, so that's up here. And remember, this point on our unit circle up here is going to be the point 0, 1. So if you go back to your unit circle, if you don't remember, the tangent was undefined. Okay, so that means the cotangent is 0. Okay, so this is minus 0. And then here you have to go to the unit circle. First of all, remember pi over 6 was the one that reduced a lot. So this is in the second quadrant. Okay, that means this tangent is going to be negative in the second quadrant. And the tangent of 5 pi over 6 is the square root of 3 over 3. And we can now take the opposite of that. So what we have here is the square root of 3 over 3 is my answer. Okay, so we used our odd identity here and our periodic here. Okay? All right, let's talk about this one. If you're not allowed to use a calculator and you take a look at this problem, some of us might freak out, including myself. However, if I remember my quotient identity, okay, so here we're going to use our quotient identity. This is the cotangent of 20 degrees minus cosine over sine is cotangent of 20 degrees. Whatever this value is, it's still going to be the same decimal. So when you take one minus the other, you'll get 0. Okay? All right, last one. This goes back to the periodic property. All right. If we know that the cosine of theta, whatever this angle is equal to 0.2 when we do it in our calculator, I can replace the cosine of theta with 0.2 plus the cosine of theta, which is this, plus 2 pi. Remember, for the periodic property, you're going to have the same value, meaning if theta was, I don't know, 45 degrees, if I add 2 pi, basically I'm adding 360 degrees. So what is that, 405? You're going to be in the same place. So wouldn't that have the same value? So this is 0.2 plus, here this is just adding 2 revolutions. So this is 0.2 again. So 0.2 plus 0.2 plus 0.2 is equal to 0.6. Okay, you're using the periodic property here to get your answer.